Welcome to Bungalows for Bachelors. So, we need to know how we're going to be loading our beams and our headers and various members. Where do the loads work? How do the loads work? What are the loads? So, there's basically two types that we are going to be concerned about here. The first type is going to be point loads. These are much simpler. These are usually going to be the results of, some other type of math that we did at some point to learn about. We did some math at some point with the previous number to get to a certain point, or it's a result straight out of a beam calculation we did somewhere, and it told us, okay, by the way, here are the loads on the end of this beam. They're these numbers. Then you just take those numbers, you plug them in somewhere else. No big deal. So point loads. Well, usually those when we connect it back in and plug it in, we don't even have to enter the numbers because the software is cool. But a point load would be where I have a beam held up on two ends, and I have a single point load here. Now, we're not concerned with how necessarily wide this is. If it's a post and it's like 6 inches wide or whatever, we don't really care because in terms of what we're trying to do, it's a point load. It goes about where it goes. The numbers don't have to be perfect. So that's a point load. 100, let's say 1,000 pounds. That's a point load. That's a weight on one specific spot on your beam. That's how we're going to deal with those. So the other type are uniform loads. There's going to be point loads. There's going to be uniform loads. Uniform loads are what I'm going to talk about here in terms of tributary areas and what that word means. For the longest time, when I was learning this skill and I wouldn't call it a trade, but this process, the word tributary area or tributary width was something that was brought up in the code. I didn't understand really, but this is hopefully a simple way of summarizing it. If I have a beam like this, it's got 6 arrows on it. I need the total amount of weight on the top to be held up on the bottom. So I need 3 arrows holding it on the left, and I drew this in another video already, but I need 3 arrows holding it on the left and 3 arrows holding it on the right. The premise of tributary areas and tributary widths is an assumption that when you're trying to design something, let's say I was trying to find this spot here. I was trying to find this force. What would I do? Well, we're going to make assumptions that if your object is uniformly loaded, which means all these arrows are the same on the top, no big deals, then I want to cut the beam in half, and I want to look at how many arrows do I have on this side. I have 3 arrows on this side. So I would have some tributary width of 3, let's call it, right? And that would tell me the 3 arrows on the bottom. So that's the basic premise of the tributary width, and I'm going to give more explanation here in a second, but that's basically what we're doing. We are making an assumption that if we have a thing that's going from one place to another, half of the weight, half of the actual pounds, if each one of these arrows was 1,000 pounds, then I have 3,000 pounds on one side, 3,000 pounds on the other side, holding it up. So that's important because I didn't have to necessarily solve any complex moment equations or sum of forces. I kind of did because this is a simple example. But if this is a more complicated example, then those equations get more complicated. We don't have to do that. So the tributary width allows us to basically simplify things and say, all right, if I have some super long span with sort of complicated numbers and I'm not sure what's going on here, and halfway down, I know I've got 4 arrows and each arrow is 1,000 pounds, then boom, I got 4,000 pounds sitting on this one spot. And I would want to know that if I'm designing this guy. I'm trying to figure out how much weight is on this wall or this post or whatever it may be. So in this case, it's two-dimensional. If each arrow is pounds, we have a one use case. But sometimes we're going to break out of that dimension. We're going to go more than just in this single use case of pounds. We're going to go pounds per linear foot. That would be the next way to adapt this. And what that's going to mean is I have a wall. This is my wall drawn in 3D. That wall has studs, and we are going to want to know how much weight this wall is holding in pounds per linear foot. Well, there's probably another wall over here. Hopefully that's somewhat similar. And we're trying to figure out, change color here. It's too dark. Trying to figure out how much weight is on the other walls. So what we know is between the walls, there's a bunch of ceiling joists. That's all there is. Let's say there's no roof. It's all just some ceiling because that's just one type of weight. That's not perfect, but whatever. So that's the idea. There's two walls, and you've got all this ceiling weight spread across both of them. Well, I want to know what the tributary width is so I can get pounds per linear foot on this wall. If I look at the first joist only and I say, let's say each joist weighs 100 pounds, it's going to carry 200 pounds worth of weight total, and the design numbers we're using. So let's say 200 pounds per ceiling joist we're designing for. So that means every ceiling joist is going to put 200 pounds on our wall, right? So ceiling joists, if you're lining them up with your rafters, are going to be 24 inches on center. So what we're trying to figure out is sometimes our software is going to ask us what are the pounds per linear foot on the thing I'm designing, or what are the pounds per square foot on the thing I'm designing. We just got to know how to use those numbers and how they work. So in this case, if we have pounds per linear foot, and I know that each one of these ceiling joists is, well, I kind of simplified it. So let's say each ceiling joist was 400 pounds. That's the design number. Well, 200 pounds is going on the far wall, 200 pounds is going on this wall for each ceiling joist. So because we're using the halfway tributary area rule, I know half the weight is going this way and half the weight's going that way. So I have 200 pounds over here, but my ceiling joists are 24 inches on center, and I want to know what are the pounds per linear foot across my whole wall. What is the average uniform that is a uniformly distributed load? Yes, the load's distributed every 24 inches exactly, but because that's consistent, we're going to treat it like it's a uniform load. So what I've got is I have 200 pounds. I'm going to move the screen just a little bit. I have 200 pounds for every 2 feet. That's 24 inches on center. Every 2 feet, I am adding 200 pounds. So if I wanted pounds per linear foot, that is pounds per foot. I want those units, which is implying that there's only 1 foot here. How many pounds per foot? How many pounds per 1 foot? Well, I would just simplify this math, and I would say there's 100 pounds in 1 foot, because if there's 200 pounds in 2 feet, there's 100 pounds in 1 foot. So PLF, that's the number I would want to use for my software. That's what I'm trying to get to. That's the point of the tributary width thing here. So that's what we're trying to get to, right? Okay, so in this situation, we got 100 pounds per linear foot. Now, what if I didn't know that each joist was 400 pounds worth? Because I don't really know that. All I know is my standard areas. I know that for a roof assembly, I'm going to have, we'll talk about the dead and live stuff in the next video, but for now, I'll just take it worth my knowledge here. So 10 and 20, roof dead load, roof live load, and ceiling is usually 5 and 10 if it's not storage. Ceiling dead load, ceiling live load. So basically, what you need to know here are that these are all weights that are like in different categories, but we're going to add them all up. We're not going to do the same math with them, but for the simplicity of this calculation, I'm going to do that and show you what happens with why we want to know tributary widths and tributary areas. So let's add all these up. Actually, you know what? In the case of our example, we don't have a roof, so we're going to ignore these. We're going to say the ceiling dead load is 5 pounds per square foot. There's a unit here, PSF, PSF. So where do these numbers come from? The code tells us these numbers. The code says, well, when people build houses, this is typically sort of what ends up being the weight of the ceiling on average, plus the sheetrock and any wiring or boxes or stuff that's up there. If I have an attic, I'm going to bump these up to 10 and 20, or maybe more than that if I'm going to put a bunch of stuff in my attic. So it's trying to account for the weights that come and go in a house and the weights of the actual members themselves. And these are just the numbers they say to design with. So we take their numbers and we work with them because they're safe. We can use their numbers. That's from the International Residential Code. So 5 pounds per square foot and 10 pounds per square foot together would be 15 pounds per square foot. And I'm simplifying the math here for the sake of the explanation. So instead of knowing, I would like to delete these, but I'm just going to, I'm just going to keep drawing over here. So I would like to know, I'm not going to do the studs this time. I'm just going to draw 2 walls. Great. So I have 15 pounds per square foot of weight for ceiling area. So if I'm looking down on this example, I have the left wall. Wow, that's not straight. Undo that. I have the left wall, the right wall, left wall, right wall, and then I have all the ceiling joists going across. This is a top-down view. So what I want to know is I'm trying to design something I'm trying to design the left wall, right? Something over here. Maybe it's a beam, maybe it's something, but it's holding all that ceiling joist. So I'm trying to figure out what are my pounds per linear foot along that wall, or what are the pounds per square foot and the tributary width that allow me to get to that number. The computer will accept 2 different values. So to get it's basically the same thing. So what I'm concerned with here is, well, the first thing I need to know is what's the tributary area that's affecting my left wall. where's all the weight coming from that is on my left wall? Well, that is this side, right? That's the tributary area that is loading my wall. So sometimes I need to know the tributary width. Well, basically what the tributary width is, it's the distance of that area like away from the object I'm trying to find. So I'm trying to find pounds per linear foot along my wall, which is up and down in this case. So I need to go how far out to the side? What is the width of that area that I'm adding here? Let's say this was 10 feet. The tributary width is 10 feet. Now, if I'm trying to find pounds per linear foot along my wall on the left side, I don't really care how long the wall is, because if this pattern continues, the pounds per linear foot stays the same. It doesn't matter which part of the wall I'm in. I know that I have the same load uniformly coming over onto the left wall, and it's going to be 10 pounds per square foot or whatever here, and it's going to be 10 pounds per square foot over there. That's the whole point of the uniform load. So if I, well, first thing is I got to find that number. So what is my current pounds per linear foot on the left wall? Well, I have enough information now to find it. I know that this is 10-foot width here, and I also know that that my ceiling assembly is going to weigh 15 pounds per square foot in this area. So how would I know pounds per linear foot? Well, let's do the math here. Let's do some units here. I will show you with a quick example. If I technically, it's written out PSF, but what I have is pounds per foot squared, right? 15 pounds per foot squared, pounds per square foot, whatever you want to call it. That is the weight on this red dashed area that I have. Every square foot, there are 15 pounds. And I don't know this dimension. I don't know the length of the wall, but I'm not concerned with that because I only need to know the pounds per linear foot. So how do I find that? Well, if I need pounds and feet, pounds per linear foot, pounds per 1 foot, well, the units are telling me that I basically need to get rid of one of the foot squared guys on the bottom. So I need to be multiplying this 15 pounds per square foot by some number with feet in the units. If I take this and I multiply it by some number, oh, come on, you, and I multiply, do the old X, by some number feet, then I will end up with a number that has some number of units pounds per foot, because that foot will cancel out with one of these feet and you'll end up with pounds per foot. So the units tell me that. But which number do I use? Well, in this case, I'm trying to find pounds per linear foot along this wall, and there's a 10-foot number down here that's very conveniently in the units of feet. And if I take essentially what I'm going to do here, I'm going to zoom in on this. Zoom in here. Okay. So what I'm trying to do is I'm trying to find out the pounds per linear foot along this wall, right? So in a quick sense, what I really want here is, let's say these ceiling joists were 12 inches on center, which would be kind of dumb, but it simplifies our math here. That means every ceiling joist is a foot apart, which means every load the ceiling joist puts on the wall is the pounds per square foot. Sorry, the pounds per linear foot on the wall we're trying to find. So if I have 10 feet, then that means I have, let's take this ceiling joist right here. So I'm going to draw some little squares here. Let's pretend I'm drawing 10 because I don't know if I have space to draw 10, but I'm going to draw a bunch. And we're going to assume it's 10. I'm doing a bad job of doing it evenly. So what's happening here is I'm taking a bunch of small tributary areas. I'm saying that, halfway between this ceiling joist, I didn't draw the square the right size. Halfway between this ceiling joist and this ceiling joist, the weight's going to go over to this side. Halfway between this one and this one, the weight's going to go over to this side. So if I have 10 of those, because I have a 10-foot tributary width, then, and I have 15 pounds per square foot, each box is a square foot, then I have 15 pounds in each box. And that repeats for every box. So what would I do? How many boxes do I have? I have 10 boxes because I have a 10-foot width here. So if I have 15 boxes, each box is a foot, and I have 10 feet, I'm going to take 15 and I'm going to multiply it by 10. I have 15 pounds in each one of these, which is going to give me 150 pounds right here. Does that make sense? I hope so. So 150 pounds happens right here because of this joist. Now, if my joists were not 1 foot apart, then my area is still the same. Like my pounds per linear foot is going to still be the same. And here's why. So in this case, each joist is 1 foot apart. And I know I'm saying this and sort of being redundant here, but I'm trying to make sure this is really driven home. if each joist is 1 foot apart, and I have this example of the 10, 15-pound blocks sitting on one joist, it lands on the wall, then 150 pounds on the wall. Well, each joist is a foot, so 150 pounds per linear foot. Great. If my joists are 24 inches apart, 2 feet instead of that, what is the pounds per linear foot on my wall? It's still 150 pounds because the math is going to double for each joist, and then it's going to cut in half because each joist is 2 feet apart. And I'm going to draw that so that it hopefully makes it's nice and clear that that's happening here. So let's draw only a few here. So these are 24 inches apart, and this is the halfway point. There's another wall over here with the ceiling joists. So I want to find pounds per linear foot on the left wall, and I have these ceiling joists here. They're 24 inches on center. I have the same 15 pounds per square foot of ceiling area. That doesn't change. The area is the same. So what's going to happen here? Well, I want to find pounds per linear foot on the wall. I still have, let's call it 10 feet, still have 10 feet here. So I'm going to draw my tributary area boxes for each one of these things. So what I'm going to do is I need to know the halfway point between these ceiling joists and the halfway point between these ceiling joists because I'm doing the one in the middle here. And I know I'm going to cut it up every foot. So the first one is here. It's going to go out a foot, come up to that line. So what I'm doing is I'm finding out how much area. This is a very complicated way of doing this, but I'm trying to do the math, prove the math here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's say that's right in the middle. So those are my 10 boxes from my 10 feet coming out. Each box has a 1 foot dimension right there. Now, this dimension is 2 feet, right? Because each joist is 2 feet apart. All I'm doing is taking halfway to one, halfway to the other. Halfway to one would be 1 foot. Halfway to the other one would be another 1 foot. The total, oops, those are inch marks. Ignore the inch marks. I need feet here. So there's another 1 foot. So I got 2 foot, right? So now I have a rectangle that is 1 foot by 2 feet. And I have 10 of them. So what's that going to do to my math here? Well, I know I have 15 pounds per square foot, right? Well, where's my square foot boxes? If I were to divide these all in half here, each new box here, that box, that box, that box, that box, each one of those is 15 pounds, 15 pounds per square foot. So what happened? Well, now I have a ceiling joist and I have 10 on one side and 10 on the other side. So I actually have double the weight on my ceiling joist. But I still have 15 pounds per square foot of ceiling area because it's that is a consistent number no matter how you are going to lay out your joists. 15 pounds per square foot needs to apply to the whole area of your ceiling. So now I have effectively what I have is each box, if I were to not have divided them, each box is actually 30 if I just combine them, right? Top and bottom, add them together is 30. So I have 30 in each box and I have 10 boxes. Well, so how much weight do I have sitting over here? 300 pounds. I have 300 pounds every 2 feet because my ceiling joists are 2 feet apart, which is how many pounds per 1 foot? It's 150 pounds per linear foot. It's the same number as up here. It's the same 150 pounds per linear foot. So what I'm showing here is it doesn't matter what the ceiling joist spacing is. What matters is this tributary width, 10 feet. You need to basically imagine the ceiling joists don't really matter. What matters is that I have this area, black here, is that I have the same situation drawing a left wall and a right wall here. I'm not going to draw the ceiling joists because they don't matter. I have this area. I'm trying to find the pounds per linear foot along the left wall. So I need to know what's this width that's holding, half the weight's going this way. What's that width? Let's say it's 10 feet. And I know this area is 15 pounds per square foot from the code, per square foot, PSF. Then I just take 15 pounds per square foot of area, multiply it by 10 feet, and I know that all along this wall I have 150 pounds per linear foot. So the computer wants to know when you're doing a beam calculation or a wall calculation, whatever it is, it really wants to know that uniform load because that's what it's going to do its math with. So there's two ways to input that number when we get around to it. Either you do the math yourself and you say, okay, if I got 15 pounds per square foot and a 10-foot width, then boom, I know I have 150 pounds per linear foot. So I'm going to tell the computer that I have 150 pounds per linear foot. I'm going to tell the computer that. That's the number I put in. Or the faster way is the computer will ask, what is the load in pounds per square foot of the area that you're doing? You just put in the loads from the code. You say this one, this is the weight per pounds per square foot. And then it says, what is the tributary width? You put in the numbers of the tributary width. And then it's going to do this part for you. Now, that's useful because we can't just combine 5 and 10 because we do math with them separately. So it's useful in that regard. So that's why we're going to do that. But that is basically how tributary widths work. If you have other questions, you can always ask me on Zoom calls.